All right. I think we left off with this problem on Thursday. Is that right? First of all, you guys have a nice Easter? Anybody do it? Who did an Easter egg hunt this weekend? Got to. Scavenger hunt? Anybody do a scavenger hunt? Eat too much chocolate? Yeah. It's a good problem to have. All right. We have two triangles up here. Have you guys had time to look at this problem? I forget if we got, I know like we had it up on the board. I forget if we actually did it on Friday or Thursday. I don't think we did it. So take a look at it. We got through it all? How many of you guys have an answer for this one? Might have had time to like try it. Take another look at it. You'll see a problem similar to this. So you have Katie. Katie's doing a couple transformations, trying to figure out what are the values of K, P, and Q. On the OST, this is like the 2019 released items. I think it's like number 14 or something. Yeah, 14. This is when we were just scrolling through. We didn't actually, I don't think you guys actually did this for homework or anything.
Well, we were doing this on class and trying to provide the piece for do this one already.
What'd you get?
I mean, it's probably wrong, but so I got 2 for K, and then like dilated by 2, and then P, so I got 4 units to the right, and then Q, I got 3 units down.
Bless you. Let's take a look. So we have triangle ABC. First, she rotates triangle ABC 180 degrees about point A. This is weird because they're trying to like get you to think outside the box here. Like we've always rotated, dilated from the origin, right? But what happens if you rotate about point A? Remember how I explained this like it's like a clock? Like point A is now the very center of that clock. And as that hand rotates, the center of the clock doesn't change, right? All the hands are attached at the center. That point doesn't change, does it? So point A, if you rotate about point A, do you agree point A is not going to change? But you have to think, okay, what's point B doing? Well, 180 about point A. Let's do C first. Wouldn't C end up rotating this way over to here, right? And so you can kind of picture what's happening here if you think about it in that context where A is like the center of your clock. Next, I said rotate. Then she dilates by a factor of K with the center of dilation at point A. Okay, well, we're still dilating about point A. Do you still agree A doesn't change? Right? Now once we dilate, things are changing size. So Levi says K was 2, meaning whatever the point was, now it's the X values doubled and the Y values doubled. How many of you guys got 2 for K? I agree. K is 2. All right, K is 2. How about P and Q? Well, then she translates A double prime, B double prime, C double prime. Are we familiar with that notation? Remember that? Okay. The second transformation. P units to the right. Well, do the easiest one. Like, do you agree after this step and this step, point A still hasn't changed? So take the easiest point, point A, and see where it needs to end up. Well, in triangle ABC, A is here. Where does it need to end up?
2.
A needs to turn into what letter in the big triangle? C. You all agree? A needs to turn into C. Is that how you did it, Levi? So you went from A to C. We needed to go over 1, 2, 3, 4. 4 units to the right. P is 4. And Q units down. Well, if it went over 4, now it needs to go down 1, 2, 3 to end up on C. So usually they'll have one of the points that's not really difficult to calculate. You could have done it with any of the 3 points. A is probably the easiest one. Questions on that one? So you'd fill in 2, 4. What's Q? -3. Make sure you put -3. Okay. Because you said 3 units down. Since there's no option for up or down, we have to give it a value of a negative. So that's transformations. All right, I want to review this one with you guys as well. I don't think you have had a chance to look at this one, have you? No. All right, let me see if I can enlarge it a bit. Read the prompt, and then we'll scroll down to the options. Good old Dwayne. Which one of you guys was named Dwayne? Is it?
Why? That's pretty rude. He's like, I thought you were take your charger.
It's a genius charger.
That's pretty cool. Which one's supposed to do? Then tell him. That's what I was thinking.
I already paid $30.
All right, you ready for the options? I want to review one quick thing with you guys because when you guys did those end of the 9 weeks, what did they call them? Quarterly checkpoints, I guess it was. Something we struggled with was the difference between an angles measure and the cosine of the sine of an angles measure. So let's say we have a solved triangle like this, and call it D, E, F. And let's say this is 5, 7, and 3. All right. Make sure it's going to make a triangle. 5 plus 3 is greater than 7. Perfect. All right. What is the sine of D? What is the sine of D? Okay. 3 over 7. Perfect. So opposite hypotenuse. The sine of the angle, remember we put our finger on the angle we're talking about, it's angle D. Opposite over 3/7. If I say what's the sine of D, you say 3/7. If I say what's the measure of angle D, do you remember how to do that? It's been a while. Sine inverse. Yep, sine inverse. And if we sine inverse the left side, it gets rid of that sine. And we sine inverse the right side. So these cancel. We get angle D is, and just out of curiosity, what do you get? 23.2? Ella disagrees. What'd you get?
She disagrees.
I got 25.4.
25.4. 25.4.
Oh, wow.
25.
I had to type it myself. Be sure. Hey guys, you should all have your calculators out, checking along with us. I think 25.4 would be fine. degrees. If you put 0.38, that's fine. So angle D is 25.4. The sine of D is 3/7. What's the cosine of E? 3/7. Do you remember that relationship that the sine of A was equal to the cosine of B if they were the acute angles? Remember that? The sine of D equals the cosine of E because they're the acute angles in this right triangle. Okay, we good with that? So there's a difference. The cosine of an angle is this ratio. Quick question for you. You're heading into Algebra 2 next year. You're going to be doing what's called the unit circle. And you're actually going to learn, we didn't talk about this at the time because it's not for this class, it's for Algebra 2, but the cosine of an angle, the cosine in general, and the sine, and they have graphs. Remember how y equals mx plus b had its own graph? It's a line. Ax squared plus bx plus c, you learned last year in algebra. It was a parabola. Ax squared plus bx plus c. It was always a parabola. Remember that? Or upside down? Okay. The sine and cosine graphs have their own graphs as well. All right? Okay, they're kind of like, they're called sinusoidal, but they're like this, kind of like waves. Okay. What did we notice? Sine and cosine, when we typed in the cosine of an angle or the sine of an angle, that ratio, which is, this one's a little under a half, right? A little under 0.5. What numbers was it always between? Sine and cosine. It's been a while, and we didn't talk about this much. Here, let's back up. What's always going to be greater, numerator or denominator? For sine and cosine? Denominator. Why? Because it's always over the hypotenuse, and the hypotenuse is the longest side. What happens when you have fractions where the denominator is always more than the numerator? The fraction's always less than 1. Yeah. So all these decimals are always going to be less than 1. So that's going to give us information for next year about what values sine and cosine have to stay between when you type them in. To be continued. All right, so this one. Nope. All right, for this one. First of all, they're similar. Similar, you should be thinking same shape, different size. Okay, proportional. Angles are all the same. Sides are proportional. So if they're similar, there must be some ratio. Next step. The cosine of C is 0.92. Meaning if I have my finger here, the ratio of blank over blank is 0.92. What is that? What's the ratio? X over 20. Do you agree? X over 20 we could substitute in for cosine of, isn't the cosine of C X over 20? Do you agree? I'm getting confused looks. Tally.
Well, isn't cosine adjacent over hypotenuse?
Yes.
Oh, I see where the x is now.
Sorry? X over 20 is the cosine of C. Everybody agree? All right. Let's keep reading. Dwayne claims that the value of x can be determined, but the information provided is not sufficient to find the value of y. What's your first reaction to that? Would you agree or disagree with that? Disagree here? You guys disagree? And here's my thinking. If I know the ratio of x to 20 is 0.92, I could probably find x. Do you agree with that? Mm-hmm. And then if I have these two sides, couldn't I find the proportion that gets me, like if I knew x, couldn't I find the proportion that gets me from this triangle to this triangle? If I knew x. Yeah. And then I could use the same proportion to get from 20 to y. You see that plan? That's kind of what I'm thinking here. Let's read all the options and see. Read through them and let me know what you think. So Dwayne's claim is that it's the value of x can be determined, but it's not able to. We're not able to find the value of y. Olivia, you think C? Was anybody thinking his claim was correct that there's not enough information to find y? All right, so we've narrowed it down to what right now? C and D. Who votes C? Who votes D? Ooh, half and half. I want to hear both arguments. Who votes C and has an argument for why? Yeah.
I know. Never mind. Because the denominator is always that's a good.
Anybody want to rethink C or D?
Yes.
Which one did you vote for? Why are you rethinking that now?
Because the first C is 20 over x, and it's supposed to be x over 20.
So the cosine of C, the ratio should be adjacent over hypotenuse. It should be the adjacent side to C is x, and the hypotenuse is 20. I would agree with that. So we have D as an answer right now. What if they didn't? Hypothetical. What if they had the correct ratio right here? If we kept reading, let's check the y over 45, okay? And since the triangles are similar, this ratio will be the same as y over 45. So if they did x over 20, shouldn't the cosine of, do you guys think the cosine of r is going to have the same ratio as the cosine of C? Let me say it again. Will the cosine of R have the same ratio as the cosine of C if these triangles are similar? This is one of those things we didn't explicitly talk about, but it's something you should be able to figure out. Okay? Here's how I would approach this as a student. This is what I would hope you would do. If you don't know, let's dilate this triangle by a factor of 3. All right, we're going to call this one A, B, and C. If I dilate this by a factor of 3, the hypotenuse is now 21. This side is now 9. This side is now 15. What's the cosine of D? We've already done it. Actually, I did the cosine of E. Doesn't matter. Cosine of D? 5 over 7. What's the cosine of A? 15 over 21. Are those the same? Who votes yes? Same. Yeah, they're the same, right? This reduces to 5 over 7. Yeah. Between two similar triangles, the cosine of the corresponding angles, the angles that go together, same, are the same. The ratios are the same. Okay? So back to this. If they're saying the cosine of C is x over 20, the cosine of R would be 45 over y. Okay? And so if we know, if we're able to find x, then we could find y. All right, and that ratio is adjacent over hypotenuse as well. All right, read this one carefully. please write something down. Like, if you're trying to do this in your head or only in the calculator, you're just asking for just a simple mistake. Right, McKenna.
Was that a pun?
What did I say?
You said sinful.
Simple?
Sinful.
I said simple. But like, oh, science, like
I
a.
was so confused. I'm like, what?
That's nice.
All right. I will take options. What would you get for angle B? Who wants to give me a first answer? Jared. I got right here 30 degrees. Who agrees with 30 degrees? Half the class? Who got something different? Emma?
You said 45.
45 degrees? Jared, what did you do to find B?
I did the sine of -1 times 0.5. Like the inverse sine.
Well, why'd you do sine inverse of 0.5?
Because the cosine of A is equal to the sine of B.
So he said the sine of B is also 0.5, right? There's a couple ways to do this one. You said, and again, I would just be safe and I would draw out a triangle. A, B, C. The cosine of Jared, what was it? Cosine of A was 0.5?
Yeah.
So you're saying if the cosine of A adjacent hypotenuse is 1/2, then the sine of B is the opposite over hypotenuse. And look, the ratios would be the same, wouldn't they? 0.5. And you didn't want to solve this one to find A. You said, I'm going to take the sine inverse of both sides and get the sine inverse of 0.5. And you said that was 30 degrees. Yes? Okay. Now, could you have done this? Could you have said the cosine of A is 0.5? Let's find the cosine inverse of 0.5. Come on. Type in cosine inverse 0.5 and say, oh, that's 60 degrees. 60 degrees. That's angle A, isn't it? That's angle A. Well, if angle A is 60, what's angle B? 30. They're complementary. You could have done it that way too. So, everybody listen very carefully. Be careful. Sometimes in the problem they're going to say, what's the sine of B? And you're going to say 0.5. Yes? 0.5. Here they said, what's the measure of angle B? Okay, now you actually have to solve that angle. Sine inverse, cosine inverse, depending on which angle you're working with. And you should get 30 degrees. Okay? Good on that one now? Did that one already? Did that one already? Did that one already? Did that one already? And that test is done. All right, quick refresher, and then we'll wrap it up. Quick refresher on the formula sheet. You should get a formula sheet. If your proctor doesn't give you these things, please ask for them. Formula sheet, graph paper. Okay? Just, it's a lot as a teacher to have to proctor these different tests and to have to know which test you give what to the students. Okay? It's a lot. So very respectfully, if your proctor forgets to give this to you, just say, could we please have a piece of graph paper or formula sheet? and they should have those things for you. All right, they're ready to go in the resource room down there. I know they're there. Just make sure that they provide that to you. Make sure you have your calculator. Okay. Yes, last resort, there's a calculator on here. You don't want to have to be jumping back and forth on this test to a calculator. It's just annoying. All right. 2, on the formula sheet, you shouldn't really need any of these units of measures. Trig, if you forget SOHCAHTOA, it's on there. All right. Special right triangles, you're not going to have to necessarily know them per se. They may be helpful, but all it is it's an extension of SOHCAHTOA. We're actually going to be doing this right after. Actually, next week we'll be doing special right triangles and some more with trigonometry. Just ran out of time. Don't forget, if you do have a volume problem, you go to the formulas and you remember that capital B is the area of the base. So if it's a circle, it's a pi r squared. If it's a little b, it just means like the base edge length, like the side length of the base. Like a triangle has a base and a height. All right. Okay.
Does the geometry test usually take the full 2 hours?
It's changed over the years, and I don't know how to answer that now because every year they keep changing it, and I don't know if they're shortening it. Like I was told the history test this year was really short, like shorter than usual,
It was like 20 minutes.
and I don't know why. So I don't. They don't really tell us much of anything. So I don't know if the geometry test is the same length, different length. Like it's been 30 questions in the past. I don't know if it's going to be more or less. Like this release test we just did, I'm trying to remember how many were on there. Like this release test had 20 on it, but I don't know if 20 was the last question. You know, this is only the ones they released to us. One thing I would say about graphing problems, if you forget a transformation, like if you forget, hey, I need to rotate this 270 degrees counterclockwise, okay? You could take a point, graph it, like say take a sample point in like the first quadrant. Don't make it like the same x and y value. Don't like do 4, 4 or 5, 5. Do like 5, comma 2. And you could label that and like call it point A. And then say you forget what the rotation rule was. You could physically like you should picture it with this graphing calculator on here. But you could also graph a new point and test it and say, you know, if I were to take a line segment connecting to that point and I wanted to rotate it, let's see, 90 degrees would be about there, 180 would be about there, 270 would be about there. So this point should end up in this quadrant. Like that should at least help you remember the rule. Do you understand what I'm saying there? And if you can get the 90, if you can remember the 90-degree rotation rule, which was xy turns into you give me an answer and we'll test it. This is what I want you guys to do. So 5, 2 should turn into, I hear negative 2, 5. Does that look right to you? So here's what you should be able to do. Say 5, 2, this x and y turned into, if you can get this point, you can make the rule. Negative 2, 5 would be the opposite of the y value, right? We took the 2 and made it negative. Bless you. And then the same x value. Right? So you took 5, 2 and you made it negative 2, 5. Does that make sense? So couldn't you do that again with this point to take it from there another 90 and get to the 180 rule? If you forgot the rules, okay, you can keep doing 90s multiple times to get the other ones if you forgot. Don't forget the Desmos calculator for that kind of thing. All right. What else? That was transformations. We reviewed trig today. Circles. A couple of formulas first. The distance formula. I bet most of us remember that distance is the square root. We have x2 minus x1 squared plus y2 minus y1 squared. And don't forget that and the circle, the equation of a circle, are very closely related. Isn't this just squaring both sides away from this? Do you agree? This is any x, y on the edge of the circle, and h and k is the center of the circle. So it makes sense that the distance from the center to the outside is a radius, and that radius is the distance between those 2 points. All right. The midpoint formula. Don't forget, when you find the middle of something, you add them together and divide by 2. So if you want to get the midpoint, you add the x's and divide by 2. You add the y's and divide by 2. All right, those are some key formulas to remember. Cross sections. Cross sections. If they say, what's the cross section sliced vertically or perpendicular to the base or parallel to the base, be able to visualize what those look like. If I slice this parallel to the base, if I slice a cylinder parallel to the base, I get a circle. Very good. If I slice it perpendicular to the base, I get a rectangle. Mm-hmm. You see it? Ellen, you good? If you take a cylinder, if I slice it like this, it'll hit the cylinder here and here, and then it'll hit here and there. And when you look at it, I should have drawn it. I'm going to draw it this way. I guess I can't really do that. When you slice it here, the part of this you're going to see is there, and then it's going to exit the back there. Right? And so this top, you'll have, if you look at it from the side, it's a rectangle. Okay? This distance across the top is the same as the distance across the bottom. And then going up is the height of the cylinder. So those are the same, and then these are the same. What happens if you slice a cone? What do you get? Say it depends on how you slice it. Thank you. Good. What if you slice it parallel to the base? You get a circle. If you slice it perpendicular, triangles. Good. Good. I think you guys are ready for this. You guys are ready for this. Any questions in general? One other thing. Hold up a second. Hold up a second. What are you doing?
Well, I'm going to make sure you
Sure, Olivia.
You know how when first test you get like number score like you need like 5 graduates? It's the average number that people get.
It'll be fine.
What is it?
Hey guys, make sure if you get stuck on a problem, don't panic. Just come back to it. You guys are going to do well on this, all right? You guys are going to do well on this. Here's what I tell all my students about state testing, and I have AP students as well. This is just a good rule of thumb. there are some problems on there you're not going to know how to do. Okay? They don't want this to be an average. Like, listen, this is important for you to know, to understand how to not get frustrated. If the national average or state average was a 97%, would that tell you, of the students in Ohio that took it, who the best of the best is? No. What if the average was a 30% and someone got a 97% on it? Wouldn't that tell you, wow, they're really way above average? That's what they're trying to do. I'm not saying that 30% is average. All I'm trying to say is they're trying to separate into layers the abilities of students. So there's going to be some problems on there that are going to be hard. All right, don't get stressed out about those. Star them, circle them, whatever. Write it down on your piece of scrap paper. Come back to it later. All right. Use those kind of strategies and don't get frustrated on it. You got this.
I can't get any of these. Zero of them work.